All right, today we're going to look at Chapter 7, Part 2, Day 1. We're going to talk about sample proportions. So first off, the mean of the sampling distribution of P is what this symbol is. So this is the mean of the sampling distribution of P hat. All right, and that is equal to P. And then the standard deviation is this symbol. So standard deviation of the sampling distribution of P hat. So, things that we've learned before. So again, going over the formulas, mu sub P hat is equal to P, right? The standard deviation, sigma sub P hat, is equal to the square root of P times 1 minus P over N. And if P is not given in the problem, then P is assumed to be 0.5. Right? And then next, that is true as long as the 10% condition is satisfied. So if that 10% condition is not satisfied, then we don't get to use that formula. And then finally, along with this one, as N increases, the sampling distribution of P hat becomes approximately normal. So we have to check these normal conditions. N times P has to be greater than or equal to 10, and N times 1 minus P has to be greater than or equal to 10. So again, we want to check for these conditions, making sure that the 10% rule is satisfied, and we also need to make sure that it's normal. If it's not given that it's normal, then we have to check to see if it's normal using this N times P and N times 1 minus P. Alright, so let's look at number 8. Alright, looking at number 8, it's easier to understand number 8 if you reference the picture on page 435. It's in blue, kind of example problem in your book. And if you look at the picture, they're talking about the sample size being 25, and then it talks about 400, and then it has like a pi symbol, and it says 0.15. And if you look at the arrow in the middle of the picture on page 435, you'll see that it's pointing to 0.15. Now, it's saying that, would we be surprised if we got 32% instead? So if you look at that picture and you find about where 32% is, there's only, I don't know, it looks like maybe 3 or 4 candies to the right of 34%. So would we be surprised? In that case, yes, because that number is so small that the likelihood of it actually occurring by chance alone is very small. So we're surprised that it would actually happen in real life. So would we be surprised? Yes. We would be surprised, right? Because the probability of it occurring in real life is so small. Now, how about 20%? Would we be that surprised? So we see that 20%, 0.2, is much closer to the mean, and it'll be a higher percentage, right? Much more than 5% if you look at the percentage of shaded area from 0.2 over, right? Picture it being shaded. So the 0.5, our answer is no, we're not surprised, right? Because there are many outcomes at 0.2 or above, right? And this one over here, we would be surprised because there are very few outcomes at 0.32 and above. So kind of that same thing that we've been talking about since we learned what statistically significant meant. All right, now to make sure that you're understanding what we're talking about, I would like you to do part B on your own, and let's go over that tomorrow in class. Make sure that I feel like you understand what's going on. All right, let's look at number 9. Suppose a large candy machine has 15% orange candies. All right, so imagine taking an SRS of 25 candies from the machine and observing the sample proportion P of the orange candies. What is the mean of the sampling distribution? So we know that mu sub P hat is equal to P. So suppose a large candy has 15% orange candies. That's P. So therefore this is 0.15. Right? Because the mean of the sampling distribution is the same as the population proportion. That's the reason why. All right, part B. Find the standard deviation of the sampling proportion of P hat. So first, we have to make sure that the 10% condition is met. Because if it's not met, then we can't use that formula. So you take the sample, 25 times 10, and you get 250. So is it likely that the population would have at least 250 candies? So it is very likely that the population contains at least 250 candies. So because it's therefore independent, really remembering that's what that is, then we can go ahead and use the formula. So sigma sub P hat is equal to the square root of P times 1 minus P divided by N. So the square root of 0.15 times 1 minus 0.15 divided by N, which is 25. Don't know why I put that there. Let's get rid of that. Equals, and you just put that in your calculator, making sure to use parentheses and close parentheses as needed. 0.0714. All right, so then part C, is the sampling distribution of P hat approximately normal? Well, it would be nice if they told us that, but they didn't, so we have to check. So remember that the normal condition is that N times P has to be greater than or equal to 10, and, remember the word in and requires that both must be true. N times 1 minus P also has to be greater than or equal to 10. So both of these must be true. You have to choose, you have to look at both. So N was 25, P was 0.15, and we have to make sure that that's at least 10. So you just multiply them together, and we end up with 3.75, which is less than 10. So, therefore, not normal. Once the first one fails, I don't need to check the second one because the word and in math implies both must be true. And since one failed, then ideally, you don't have to check the other one. All right, now for part D. If the sample size were 75 rather than 25, how would this change the sampling distribution of P hat? So we would know that the mean would stay the same. So mu sub P hat would still be 0.15. The spread, the standard deviation, will change because remember, as sample size increases, standard deviation or variance decreases, right? The amount of variability. So since standard deviation is a type of variability, the standard deviation should get smaller. So we have our 0.15 times 1 minus 0.15 divided by 75 now, which is now 0.0412, which got smaller. And now let's go ahead and check and see what about normal. So N times P is greater than or equal to 10. N times 1 minus P is greater than or equal to 10. So this would be 0.15 too excited. No, I was right. Okay, so 75 times 0.15 is greater than or equal to 10. And then we need to check 75 times 1 minus 0.15. See if it's greater than or equal to 10. You must show your work here. You have to actually plug these numbers in. So if you didn't plug the numbers in, you would get gigged. So make sure to show this work. So we know that this is at least 11.25, which is indeed greater than or equal to 10. And this one over here is 63.75. Notice that the sum of these two makes 75. So therefore, the distribution is approximately normal. Be careful when you say this. I always just say that the distribution is approximately normal because you want to make sure that you don't use the word sample distribution or sampling distribution out of context. So, all right, therefore approximately normal. All right, so let's look at number 10. In the game of Scrabble, each player begins by drawing 7 tiles from a bag containing 100 tiles. There are 42 vowels, 56 consonants, and 2 blank tiles in the bag. Kate chooses an SRS of 7 tiles. Let P hat be the proportion of vowels in her sample. Is the 10% condition met? So, remember that you take the sample size. In this case, the sample size is 7. Take that times 10, and that equals 70. So, since the population is 100, the 10% condition is met. 10% condition is met since there are at least 70 tiles in the population. Right? Other ways you can write it, I just like to use kind of the same language each time, so that way when I come to a problem like that, I know what to do. Is the normal condition met? So remember that the normal condition is n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So, on this one, if you think about what is happening in this problem, it's going to be 7 times some proportion of 7 is going to be greater than or equal to 10. So no matter what p is, p has to be less than 1, right? Because thinking about it being a percentage. So the fact that the sample size is 7 by itself, it already has failed the condition for normality. So it doesn't even matter what p is because 7 is so small. So 7 is too small. Therefore, violating the condition for normality. So most time you'll plug it in, but because, 7's not even 10, it doesn't matter. You're going to only take a portion of that 7, understanding what P stands for. So you're never going to get more than 7. The highest that you can ever get is 7. Hopefully that makes sense. All right, so now the Gallup poll. The Gallup poll asked a random sample of 1,785 adults whether they attended church or synagogue during the past week. Of the respondents, 44% said they did attend. Suppose that 40% of the adult population actually went to church or synagogue last week. Let P hat be the proportion of people in the sample who attended church or synagogue. What is the mean of the sampling distribution of P hat? So, mu sub P hat is equal to P. And that can be our y part. If you want to write that out in word form, you can. But other than that, that's the definition of what the formula is. So, mu sub P hat is equal to 0.40. Find the standard deviation. So we can only find the standard deviation if that 10% condition is met. So first thing we have to do is check the 10% condition. So, our sample size is 1,785 times 10 equals 17,850. So, assuming there are at least 17,850 adults in the population. Okay, so the 10% condition is met, assuming that that's true. All right, now we need to do the standard deviation. So sigma sub p hat is equal to the square root of p times 1 minus p over n. So you either have to write the formula out like I did, or write the formula and show your work, or just show your work. Whichever is easiest. But you have to at least show one of these problems with the square root here. So I'm going to do both ways just so you can remember where I got this stuff from. So I'm going to use the 0.40 number because that is the number from the population. So don't get confused with the 0.44 number, which is the number from the sample. So we want from the population times 0.6, because that's 1 minus 0.4, over n, which is 1,785. So we put that in our calculator and we get 0.0116. All right? So the 10% condition is met, so therefore we go ahead and follow by doing the formula for standard deviation. Is the sampling distribution, a little typo, of p hat approximately normal? So it didn't say it was normal, so we have to go ahead and check. We have to do n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So again, you have to write this out. You cannot skip this part. And then we also have to plug in the numbers. So we're going to take 1,785 times 0.4. So again, notice that we use the 0.4 number. And we're looking to see if that's greater than or equal to 10. So I have 714, which is greater than or equal to 10. So you have to show this step as well, where it's larger. So don't leave out these steps. And then we have 1,785 times 0.6. We have to make sure that it's greater than or equal to 10. So again, we put that number in our calculator, or we can just take 714 and subtract it from 1785. And we're going to get 1,071, which is greater than or equal to 10. Therefore, approximately normal, right? Or you just rewrite this sentence, spelling distribution right. So now we want to find the probability of obtaining a sample of 1785 adults. So as soon as you see this, we have to start thinking z-scores, right? So the first thing now we're going to find, as soon as we see find the probability, we're going to find the z-score. So now this is p hat. So the z-score is going to be equal to p hat minus mu sub p divided by sigma sub p hat. Okay? So p hat is 0.44 minus 0.4 divided by the 0.0116 that we got earlier. So we put that in our calculator and we get 3.45. Right? So, or more means probability is greater than. So the probability that our z-score is greater than 3.45 is what we're looking for. So we draw a picture. Here's 0, 3.45 would be clear out here. So this probability should be really small. If it's not, pretty sure we did something wrong. So we're going to normal CDF in our calculator. Your lower bound is going to be 3.45. Your upper bound is going to be infinity using 0 and 1. And your calculator may write it in scientific notation. So your area is going to be equal to 0.0003. So you kind of are asking yourself, is this less than 5%? Right? That's only 0.03%. So clearly it's less. So therefore, it is very unlikely if the true proportion of people who attend church is 0.4, that 44% or more will answer yes. Okay? So again, thinking about what that definition is of an unbiased estimator, first you have to be able to assume or say that if the population proportion, if the true proportion is actually 0.4, then you can say whether it was likely or unlikely. And that's the reason that you have to write this is based on the definition. So, what sample size would be required to reduce the standard deviation of the sampling distribution to 1/3 the value you found above? Alright, so since the standard deviation is found by dividing by the square root of n, right? So if you have this, we are dividing by the square root of n. So if we're thinking of 1/3 that value, we need to get 3 from this. So how do you get 3 from a radical? And that means it would have to be 9 times bigger, because the square root of 9 is 3, right? So we're going to take 9 times 1,785 equals 16,065. So you're always looking for this number, and then you square it and multiply it by the sample size. Alright, so here's a problem altogether. Harley-Davidson motorcycles make up 14% of all motorcycles registered in the U.S. You plan to interview an SRS of 500 motorcycle owners. How likely is your sample to contain 20% or more who own motorcycles? So, first thing we want to do is figure out what we're trying to find out. So we're trying to find that the probability of P hat is greater than 20% or 0.2, right? And we get that from right here. All right, so we have an SRS of size 500, okay? We have P equals 0.14, and we have P hat equals 0.2, all right? So now we have to identify what P is. So let P equal the true proportion of motorcycle owners own Harleys. So always make sure to identify your variable first, right? So we're going to identify P, and then what P hat is comes from that because it's inferred that the graders know what's going on. All right, so let P equal that. So now we need to find mu sub P. Mu sub P hat is equal to 0.14. Now we need to find sigma sub P hat, assuming that's a 10% condition. So we need to check the 10% condition. All right, so assuming there are at least 10 times 500 equals 5,000 motorcycle owners. That seems reasonable, right? Okay, so the 10% condition has been met. Now we also need to make sure that it's normal. And after we do this, sorry, I skipped a step. The square root of P times 1 minus P over N. So this is equal to, make sure that you use P and not P hat. So this is equal to 0.2 0.14 I just almost did what I told you not to do, times 0.86, right? 1 minus 0.14 over 500. And we get 0.0155. All right, once you get those done, then the next step is to check to see if it's normal. So now we need normal condition. So we need to do n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So n was 500. Make sure that you use p. 0.14 is greater than or equal to 10. So that's going to be 70, which is greater than or equal to 10. Check. And then over here we're going to 500 times 0.86. Check to see if it's greater than or equal to 10. 430, it's greater than or equal to 10. Check. Therefore, approximately normal. Okay, so now we need to find the z-score. So z is equal to, and this is where we finally get to use p hat, 0.2 minus 0.14 divided by 0.0155. So we get 3.87. So we draw our curve. Here's 0. 3.87 is clear out here. Shade that little tiny area in. And now we're going to find the area. So we're going to do normal CDF. Our lower bound is going to be 3.87. Our upper bound is going to be infinity. Our mean and standard deviation will be 0 and 1. So we find that the area is really, really small. It's basically 0. Okay? So then we're going to conclude it is extremely unlikely that we would get a sample of 500 motorcycle owners in which at least 20% own Harleys. Right? Very, very unlikely. Make sure that you note that this number is scientific notation, but it's pretty much 0 since it's so, so small. Alright, so in case you're not going to be here tomorrow, this is what we're going to do. The assignment's at the end of the section 7-2. The 21 through 24 are the multiple choice questions from the end of section 7-1. And I would highly suggest doing those. Those are optional, but 27 through 41 odd are not optional.